Hello everyone, today let's solve the problem no casino in the mountains, right? So this was asked in the Codeforces round 1037 division for the division 3 basically, right? So we have solved only the problems on the division 2 as well as the division 1. I doubt that we have solved the problems recently in the DP basically in the division 3. This is going to be the first problem that we'll be solving for this one for the division 3 basically, and also this is going to be the last problem on the dynamic programming, right? So this is going to be the 50th problem. As we had discussed that we'll be solving the 50 problems on this one 50 problems on dynamic programming and 50 problems 50 problems this one 50 problems on the this one graphs basically, right? So we will be done with the dynamic programming for today. So from tomorrow we'll be starting this one, the problems based on the graph. 50 problems, 50 problems we'll be solving on the graph. And also the lead code problems I'm solving, there also we are almost done. From today we'll be solving this one, bit manipulation. Only 3 topics are left basically. One is solving the problems on bit manipulation, another one is solving the problems on DP and the graph. So competitive coding, so this one basically in the Codeforces, this is going to be the last problem that we'll be solving on the DP. I don't know when I'll solve the DP problem again for the YouTube basically. So this is going to be the, in my opinion, this is going to be the last problem on the DP. So this will be special basically, right? Let's solve this one, right? You can just go through the question. It's easier for us to and basically it's easy to understand. I'll just summarize the question so that it will be easier for us to solve the problem. So just give me a second, 1 second here. Yep. So what the question states here, Gene, see here, a guy named Gene has n days basically, right? Gene has n days, each day marked 0. Each day is marked 0, right? 0 means good, or 1 basically, right? Or 1. Each day is marked as 0, that is good, and 1 which means rain basically, right? 1 meaning rain, 0 meaning good, and 1 meaning rain. A single hike requires exactly k consecutive good days. A single hike requires exactly k consecutive this one good days, and after any hike you need at least 1 day gap before the next, right? A single hike always requires exactly k consecutive good days, and after any hike you need at least 1 day gap before the next. What we need to do here, we have to find the maximum number of hikes Gene can take. Again, what we need to do, we have to find the maximum number of hikes Gene can take, right? So that's what we need to find. So again, let me read the question loud, just listen to this carefully. So Gene has n days, each day marked 0 good or 1 rain, right? A single hike requires exactly k consecutive good days, and after any hike you need at least 1 day gap before the next, right? So we have to find the maximum number of hikes Gene can take. Sorry if I pronounced minimum. We have to find the maximum number of hikes Gene can take. So what we need to find, maximum number of hikes, right? So maximum number of hikes basically a Gene can take, right? That's what we need to find here, right? I hope the question part is completely clear, man. We need to find maximum number of hikes, right? So here, just give me a second here, 1 second. So here we have the this one example input, example 1, and the output 32002. This is fine. Output that we need to get here is this one. This is the first input, this is the second input, third, fourth, fifth, right? So the output that we need to get here is 32002. For the first one, for the first input we have to get 3, followed by second, third, fourth, fifth. Inputs we have to get the output 2, outputs 2, 0, 0 and 2. This is fine, I believe, right? So I have considered the same first example here that they have given in the question, 5, 5, 1. So this one, this is going to be the first input, second input, third, fourth and fifth, right? So totally we have 5 inputs basically. So this is going to be the second actually, third, fourth and finally fifth one, this one 6200100, right? So this is fine. The output that we need to get here is 32002 basically, right? For the 5 inputs we have got the 5 outputs. Let's move on with the step-by-step explanation here. So let's discuss the DP idea first. or the idea first, right? So then we can move on with the example part. We can consider the first example and then we can implement the idea on the first example, right? So first what we'll be doing, we'll be scanning the days from left to right, right? So we'll keep the running count of the consecutive days. That's what we'll be doing. First again we'll be scanning the days from left to right, keeping a running count of consecutive days. Whenever we have k consecutive good days, that is ending at the I, right? So that is ending at the I. So we have to consider, or will be considering, taking a hike that ends at I and combine with the best answer before the mandatory gap. So this is accordingly with the question that they have given, right? So we have to consider taking a hike that ends at I and we will be combining with the best answer before the mandatory gaps. So in the question they have given, consider taking a hike, this one, sorry, not consider taking the hike I. So this one, a single hike requires exactly k consecutive days, and after any hike we need at least 1 day gap before the next, they have said. So that is the reason what we are doing here. So we will be considering taking a hike that ends at I and we will be combining with the best answer before the mandatory gap. Mandatory gap in the sense we will be going with the I minus k minus 1, right? I minus k minus 1. So this is going to be the this one, basically criteria accordingly with the question that we discussed. So this is fine. Now let's implement the same thing with the example, right? So now let's implement the same thing with the example. Here n is going to be, so we will be considering for the 3 month, this one, the first one basically. So we'll be considering this part, the first example. So let's see how we will get the output 3 basically. So I can just implement or articulate the same thing that I show for the second, third, fourth or fifth, this one input or the examples, right? So this is fine. Now let's move on with the this one, what do we call, implementation or articulating the same thing for the this one, for the example that they have given basically, right? So this is fine. Let's go with the input. So here n we have been given 10 and k we have been given 2, and the array A here is nothing but for the first one this is going to be 0 0 1 0 0 0, 3 zeros basically, pardon the commas here. So this one 1 followed by 3 zeros, right? So this is going to be the array basically, right? For I equals 0, we have 10 total, right? So this one 0 0 1 triple 0, 0 0 1 triple 0 is 5, 0 1 triple 0, right? Sorry, 1 triple 0, basically. So 0 1 2 3 4 5 6 7 8 9, yeah, it starts from 0 and ends at 9 basically, totally 10, right? So this is fine. Expected output is 3 basically, right? So let's go with the step by step, this one. Let's see step by step what happens here. For I equals 0, for the iteration, first iteration, a of 0 is 0. See here, a of 0, the value we have is 0. So again I'll just write it over here. So this one is 0 0 1 triple 0 here, this is fine, 1 followed by triple 0, right? So this is fine. A of 0 is 0 and 0 count is 1. Now we have the 0 count is 1, right? So we'll be going with the a of 0 is 0 and 0 count is 1. So this cannot fit k yet because k we have been given 2 here. This is, see here, I have marked. So again let me write it here so that this is visible correctly. K equals 2, right? So this cannot fit k yet. So dp of 0 for the first one will be 0 itself. So this is the calculation. Let's move on with the iteration first, this one, second iteration when I equals 1, a of 1, again see here, a of 1, again we have 0. This is fine. A of 1 0, 0 count is 2. The previously we had 0 count 1, now we have 2 zeros, 0 count is 2, which is greater than or equal to k basically. We'll take hike from 0 to 1, right? So previous equals dp of, we will be going with the dp of minus 2 basically, right? So this one will be 0. Again dp of minus 2 will be 0. This is fine. So dp of 1 basically now we'll be going with max of dp of 0 comma 0 plus 1, right? So max of dp of 0 is nothing but 0, 0 comma 0 plus 1. So 0 comma 1, max of 0 comma 1 will be 1 quite obviously, right? So this is fine. Easy. Let's move on with the third iteration here. I equals 2. So a of 2 is 1. See here, the value we have here is 1. A of 2 is 1, 0 count is 0. So previously we are done with this one, taking the max and all. So again we have to start fresh. So 0 count is 0 here. 0 count is 0 and dp of 2 equals dp of 1. So basically dp of 1, the value we have here is 1 basically, right? So dp of 2 is equivalent to the dp of 1, that is nothing but 1 itself. So let's move on with the fourth iteration. When I equals 3, a of 3 we have got 0. See here, we are considering this 0. Right, so a of 3 we have 0. 0 count is 1. This time we have 0, right? 0 count, we have started fresh from I equals to 2. So 0 count becomes 1. So dp of 3 quite obviously is 1. Let's move on with the fifth iteration, nothing but I equals 4. So 0 count is 2. Previously we had 1. So 0 count becomes 2, which is greater than k basically, which is greater than or equal to k, right? So k we have 2. So we will take the hike from 3 to 4. Again, we'll perform the same thing that we have done for this one, basically for I equals 1, right? So we'll take hike. Previously we had took the hike from 0 to 1. Now as we are moving on with the fourth iteration, so we will be taking the hike from 3 to 4. Previous equals dp of 1, that is equivalent to 1, right? So which is this one. We have to consider dp of 4 equals max of dp of 3. What is the dp of 3 value? So see here, we have got the dp of 3 value 1. So this one, dp of 3 value 1, 1 comma 1 plus 2, 1 plus 1, sorry, 1 comma 2, max of 1 and max of 2 is nothing but, so we have to go with the 2 basically, right? Max of 1 and 2 is 2 quite obviously, right? So let's move on with the fifth iteration. Again we have to start fresh because we took the hike last step, right? So a of 5, see here, a of 5 we have 0, a of 5 and a of 6, again I will not come for a of 6. A of 6 is also 0. Just remember this one. A of 5 we have 0 and 0 count we have 3 now. 0 count we have 3, which is greater than or equal to k. Again we'll be going with a candidate hike from 4 to 5. Previous equals dp of 2, that is equivalent to 1. dp of 2 you can just check, it is 1, and dp of 5 is nothing but the max of dp of 4 comma 1 plus 1. So dp of 4 is nothing but here we have dp of 4 is 2, and here also we have got 2. This one will be max of 2 comma 2, nothing but we'll be going with the 2 equals. Both the values are same, right? So this is fine. Next let's move on with the seventh iteration. When I equals 6, a of 6 is 1. So again let me show it here. 0 1 2 3 4 5. So yeah, a of 5 was 0, a of 6 is 1. See here, 7 8 9, again we have 0, right? A of 6 is 1 and 0 count is 0. 0 count we have 0, right? 0 count we have to start fresh because we have went with a candidate hike, right? So this one we will be starting with 0, and dp of 6 we have here as this one 2 basically, right? So dp of 6 we have as 2. This is fine. Whenever there is no candidate hike, then we can directly go with this one value, right? So dp of 6 will lead to 2 basically, right? So next let's move on with the a of 7 8 and 9. All the values have 0 basically. 0 count is 1, 0 count this one. So dp of 7 remains same, it remains this one previous value, right? So this remains 2, and for a of 8, 0 count has become 2, and this is greater than or equal to k, right? So again we have to take the hike basically. Whenever it is equivalent or greater than k, we have to take the hike, right? So we will be going with a hike 7 to 8. Previous dp equals dp of 5 we have 2, and dp of 8 is nothing but the maximum of this one, dp of 7 comma 2 plus 1. dp of 7 we have 2, and this one max of 2 comma 3 is will be going with the 3. Finally a of 9. So as we had candidate hike previous step, we will be this one. We have to start with the fresh, but again we have to go with the candidate hike because this time 0 count 3, if we consider this one, basically k we have to consider candidate hike 8 to 9, and previous dp of 6, this remains, the previous value remains same 2 itself, but the maximum value, this one dp of 9, we have to take max of dp of 8 and 3. dp of 8 is nothing but this one 3, and 3 and 3, max of 3 and 3, we can just directly consider this one 3 itself, right? So finally we will be returning dp of n minus 1. So dp of n minus 1 is the last value, dp of n minus 1 is nothing but 3 here, the value 3, the last value that we got here, this one we have got as output, right? So basically hikes can be scheduled on the disk. This one 0 to 1, 3 to 4, and 7 to 8, accordingly with what we have discussed, accordingly with the iterations that we saw, right? So the output that we got here, this one, the last one will be considering basically dp of n minus, we have to return n minus 1, so the output will be 3. So the output that we got here is 3, which is equivalent to the output that they have mentioned for the example 1 within the question. So I can just try it out in the same way for the this one, input 2, 3 or 4, 2, 3, 4 or 5 basically. You have to get the output 2, 0, 0 or 2 basically, right? So I have shown you for the first one by considering this input, right? So 5, 5, 1, 0, 1, 0, 0, right? So this is fine, I believe. Next, let's do one thing. As we are completely familiar with the this part, what do we call approach part, let's discuss the complexity. So what will be the time complexity here? The time complexity would lead to big of n per test case. So we will be scanning the days once, doing big of 1 work per day. So this one will be scanning the days once, doing the big of 1 work per day. And what will be the space complexity here? The space complexity would be big of n per test case as well. The DP array stores 1 integer per day plus the input array, right? So overall time complexity and the space complexity for the code that we'll be writing in the future would be big of n and big of n respectively, right? So time complexity and the space complexity for the code that we'll be writing in the future would be big of n and big of n respectively, right? So now as we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code. So space complexity is big of n because people making use of the DP arrays, right? So that stores 1 integer per day, as I've said, right? Also we'll be making use of the input array. Let's see that one directly within the code, man. Right, so just remember this big of this one, time complexity and the space complexity for the code that we'll be writing in the future would be big of n and big of n respectively, right? So now let's start writing the code. So let's start writing the, I'll just come here. So first thing is we'll be going with the fast input and output, right? So let me import the input output package. Also we'll be making use of the different utilities. So let me import the util package as well. So this is fine. Next let's make use of the class here. So this one will be class. As usual I'll be going with the main. You can just give any name that's relevant to the question. So I'll be making use of the main method within the class, right? So also let me give here throws input output exception, or else we'll be getting the error basically, right? So this is fine. So within the main method, let's create a buffered reader to read the fast from standard input, as well as let's create a print writer that is wrapped in the buffered writer for the fast output to the standard input. This one standard output basically, this is related to the input output. Let's do this one quickly. So this one will be, so just give me a second here, 1 second. Buffered reader br, so new, so let me go with a buffered reader new input stream reader of, so this one will be system dot n. So this is fine. Also let me go with the print writer. So this one let me go with out equals new print writer. So this one will be new buffered, instead of reader I'll just go with the writer, buffered writer new. So this one will be output stream writer. This one will be of system dot out. So this is fine. The next step would be we have to read the first line which contains the number of test cases t and pass it to int basically. So this one will be int t equals integer dot %. So this is fine. Buffered reader dot read line. So this is fine, man. So the next step would be we have to loop over each test case, decrementing t until 0. So I'll just go with while greater than 0. So while there are test cases remaining, so we have to read the line containing n and k separated by space, right? So also we'll be splitting this one into the tokens, right? So I'll just go with string here. So this is fine. Nk, so this one will be buffered reader dot read line, let me give split here. So this is fine. The next step would be so let's parse n and k from the split token. So this one will be int n equals integer dot parse token. So this one let me go with the parse int, not parse token basically. So this one we have considered variable name nk, right? So this one nk of 0, and also let me assign k2. So this is of the type integer as well, so we have to pass this one as well, right? Parse int of, so this one will be nk of 1. This is fine. So now we are done with the input output part. Let's do one thing. Let's create the integer array a of the length n just to store the day's weather, right? So 0 equals good and 1 equals rain they have given in the question, right? So let me write it in this way. A equals new int of size n, initialization part. Now let's read the next line containing the n integers, nothing but 0 or 1. So the input is given in the form of 0 or 1 itself, and we have to split that one into the string tokens that's related to the input output. So I'll just go with string s equals buffered reader dot read line. Again let me go with split here. So this is fine. Yep. Now let's convert each tokens into the integer and store in array a. So I'll just go with for int I equals 0, I less than n. So this will be I plus plus. Again a of I, let me assign this one to the integer dot parse int. So this one will be s of I. This is fine. Yep. Next let's do one thing. Let's go with the dp of I. dp of I is nothing but it is equivalent to the maximum number of hikes that is possible considering the days 0 to I. So this one I can just write it in this way. dp equals new int of, so this one will be n, right? So let's go with the 0 count that is equivalent to the number of consecutive good days, nothing but the zeros that is ending at the current index I. So this one will be int 0 count. So this is nothing but 0 count equivalent to 0. The next step would be let's iterate over each day index I from 0 to n minus 1, right? So let me go with for loop int I equals 0, I less than n. So let me go with I plus plus. So within the for loop, if the current day is good or nothing but 0, so we have to increment the consecutive 0 counter, right? Otherwise we have to reset the 0 count, this one to 0. That's what we need to do. So let's write the simple if condition here. If a of I, so if it is equivalent to the value 0, then we have to increment the 0 count as I've said, or else what we have to do, we have to reset the 0 count to 0, right? Value 0, else 0 count here, let me give 0. Let's assign this one to the 0. Let's move on with the further things. So one thing here, we are making use of the DP, right? So we'll be making use of the DP, or we are making use of the DP currently. So by default, carry forward, we have to carry forward the best value from the previous day, right? If I equals 0, meaning the value I, if it is equivalent to the 0, then iterated value of the DP should be 0, nothing but ternary handles the base case here. So I can write it in this way. DP of I equals, if I greater than 0, then dp of I minus 1, else we have to return 0. This is fine. So the next step would be, if we have at least k consecutive days that is ending at the I, we can consider taking a hike, meaning here let me go with a simple if condition. If 0 count, if it is greater than or equal to k, then if we take a hike that occupies I minus k plus 1 to I, so previous allowed index is I minus k minus 1, right? Also if I minus k minus 1, if it is greater than or equivalent to the 0, then we have to get dp of I minus k minus 1, else we have to go with the value 0, meaning no previous this one hikes, right? So this one I can just write it in this way. Just consider previous here. This one, as discussed earlier, I'll just go with I minus k minus 1. If it is greater than or equal to 0, then we have to go with dp of I minus k minus 1, else we have to go with 0, right? So this is fine, I believe. The next part would be we have to update the iterated value of the dp or dp of I to be the maximum of not taking this particular hike or taking it. If not taking, it's fine. If taking the previous hike into the consideration, we have to go with the previous plus 1, right? So this one we had seen in the this one approach itself, right? So math.max of something that I had written, right? So that one basically, right? So where did I come? Previous we have already considered, so just we have to update the dp of I, right? So this one dp of I, so we were going with math.max of this one dp of I, also the previous plus 1. So that is how we calculated, if you remember the approach, right? So let me come out of this one entirely. Now the answer for this test case is dp of n minus 1, nothing but max hikes using all days, right? So this one will be out.println, so this one will be dp of n minus 1. This is fine. So the final step here would be, so we have to flush the output to ensure it is written out. So this one will be out.flush. This is fine. Out.flush. So this is fine, man. We are done with the coding part. This is it. So before checking the code with the different inputs, let me copy paste the signature starter template. Just give me a, I'll just come here. Let me paste this one. Yeah. Just come to the question. Let me copy this one. The output that we need to get here is, for the 5 inputs, basically we have to get 32002. Let's check the same here, or else if we have some error, we'll clear that one as well. Yeah, we are getting the output 32002, meaning we have typed this one correctly, or whatever the code that we have written works absolutely correct, right? So let me copy this one. Just come to the question. Let me hit the submit code button here. Yep, let me paste the code over here and let me hit the submit button again. I hope this works for all the test cases. Let's see. Let's wait for some time. So in the toast it is showing accepted, right? So the verdict that we got here is accepted as well. So we have solved this particular problem with a DP, pure DP, right? Classic DP this one tabulation, right? So we are done with a, so here we have went with a classical DP, right? So this is fine. Yep. And one more thing, this is going to be the special problem, and why? Because this is going to be the last problem that we are solving on the DP among the 50 problems, right? So we are done with solving the problems on the DP, right? So dynamic programming. So we have solved the DP on trees and other stuff. We have solved easy problems. We have solved this one very complex problems as well, some medium to hard based problems as well, accordingly with this one, what do we call, accordingly with the CP. I'm not speaking of the lead code based problems. For lead code based problems, every problem that we solved is difficult itself here, right, based on this. So now we are done with solving the this one DP problems, as I had this one said earlier, that we'll be solving 50 problems on the DP and 50 problems on the graph. So we have finished first main topic, that is DP. So now around 120 problems we have solved CP, right? So previously I had solved around 50 problems, correct, 50 problems using the Node.js. Now we have solved around 120 problems. I have covered mostly all the topics. We are only left with a graph, right? So we are left only with a graph, the topic advanced graph problems we'll be solving. 50 problems we'll be starting with. We'll be starting from tomorrow, basically. Now that's what I wanted to say. We have solved around 170 problems, 50 problems on this one Node.js by making use of the Node.js, and 120 problems we have solved using the Java. So again 50 problems will be solving, right? So graph problems will be solving. Totally it will be 170 plus 50 again. So we'll be solving around 220 problems. So 220 Codeforces problems will be solving, as I've said. So 220 is more than enough, man, including all the topics, I believe, right? So lead code problems, n number of problems we have solved. there is like I can't even count, right? So some problems we have solved again and again. So basically I have solved from the neat code, right? So neat code, and some of the problems I have considered myself. So basically that's the lead code, this thing. So this is my own this thing, problems list basically. And some of the problems are taken from this one blocks as well. Some of the important problems that had helped me a lot as well. They have mentioned some of the important problems for this DP. Many of the problems are considered by some particular blog actually. He or she has mentioned this one, some of the problems, these problems whatever I have solved basically based this one mainly on the DP. So these are some of the fantastic problems to solve on the DP, I wouldn't lie. So you can just practice this one, and also whenever you give contest, it will be easier for us to this one implement when you practice the problem more. Before hopping into any of this one DP or any topic it might be, right? Whether it may be sliding window, whether it may be array strings, whether it may be linked list, whether it may be trees, whether it may be graphs, DP, anything, it doesn't matter. Before hopping into any topic, make sure that you learn particular algorithm, man. So there are chances that many times we will be asked to solve the problems based on the particular algorithm these days, right? We have AI, everyone are making use of the AI, I won't lie. So even if you see the lead code, if you are giving the contest in the this one Codeforces, right? So might be that they are not making use of the complete this one complete AI, this one any this one AI tool to solve the problem entirely, but at that point of instance they are going with the AI just to learn this one. If they don't know the algorithm, to learn the this one algorithm and to implement that one. If it is based, if the question is based on a particular algorithm, or if they don't know any topic, they are making use of AI, right? AI tools, whether it may be GFG, many websites will help you in this way, right? So for the, I insist you to learn or to go through certain algorithms, certain important algorithms, so that you can implement that one in a good way, or you can implement, at least you will be knowing the name, and at least you will be knowing that we have to do in this way, in a particular way, that you will know. Even you can't mug up everything, or you can't remember everything that you do, but you can just remember in the way that your this one head remembers that you have to implement. This is based on arrays, or this is based on this one, what do we call DP. So we have to implement DP here, or we have to implement graph. This is completely graph based this one question. So this algorithm, this particular algorithm I had learned, and I have to implement this one for this. So that kind of thing you can you'll be able to remember while implementing or articulating the same thing. If they have asked particular question in the contest, that you can do, that helps in a way that implementation becomes easier, right? So you'll not take much time, and also if you have time, then you can go this one, then you can go with the algorithms that I have uploaded, right? So I am going with most of the important algorithms based on the topics, whether it may be string algorithms, whether it may be this one array based algorithms. Now we are going with the tree based algorithm. We have discussed linked list based algorithms as well. We have discussed stack and queue based algorithms as well, which consisted of this one monotonic stack, monotonic queue, this one expression evaluation, these kind of algorithms, right? So a very important algorithm we are discussing. Now we are in the part tree, this one tree based algorithms, right? So today we'll be discussing about this one, I believe. What do we call, yesterday some this one Morris traversal we had discussed, I believe, yesterday. So today we'll be discussing yesterday we had discussed on the diameter of the tree, sorry. So today also we'll be discussing one of the important this one algorithm. So you can just go through the algorithm playlist as well, right? So this is what I wanted to say. And once again, so we are done with solving the 50 DP problems. So again, so from tomorrow so it's going to be completely new. Again we'll be starting with a graph, so this is going to be new from tomorrow. So we are done with the DP problems, solving DP problems. From tomorrow let's start solving some problems on the graph. So again, to solve the graph problems you have to know certain algorithms, right? So whether it may be Dijkstra's algorithm, some of the very important algorithms, Kahan's algorithms based on this one, topological sort, whether it may be DFS and BFS. DFS and BFS, you have to know, for this comes within the trees or the graphs basically. To solve the tree problems also, you have to know the DFS and BFS. Also, while solving the graph and this thing, graph or trees, you have to know the topics recursion as well. Everything is interlinked when it comes to DSA. Most of the things are interlinked, so we have started with the arrays. So that is the reason I have started with the arrays and strings, right? Arrays, 2 pointers, this one sliding window, strings. Then we had went with basically wanted to go with a certain structure, right? So we started with the arrays, this one, then followed by the 2 pointers, sliding window, strings, then came the linked list, where we solved some problems using this one, what do we call tortoise and hare algorithm, right? So those are actually very important, right? So we have come to the last topic for basically that's nothing but the advanced graph, right? So from tomorrow, as I've said, as I had stressed this one multiple times, we are done with the DP. So from tomorrow we'll be solving the problems on the graphs, right? Also, as I've said earlier, so please do check out the algorithms playlist as well if you don't know, right? So that also we are going in certain structure. So I have started that one as well with the arrays, right? Arrays, strings, then comes this one, then we discussed on the stacks and queues, as I've said, then linked list, then now we are going with the tree based algorithms, right? This is also based on certain structure, right? So you can just go through the algorithm playlist, important algorithms playlist as well, based on the this one, data structures, right? So whether it may be array, strings, as I've said, right? So yep, let's finish it off with this particular question, right? So with this particular question, meaning no casino in the mountains, the DP problems. And tomorrow let's start fresh with the advanced graph problems, right? So for now, this is it. Thanks for watching, guys.